Come on and cry me a river. Cry me a river. I cried a river over
Good morning and welcome! How are you doing today? This Tuesday, the 3rd of March, on March the 3rd of 2026. How's everybody doing? I hope doing well. Today I have 2 articles I want to share with you or read to you. The first one is: Psychology says that 1960s and 70s accidentally produced one of the most emotionally durable generations in modern history. Not through better parenting, but through benign neglect that forced children to self-regulate, problem-solve, and develop emotional calluses that modern comfort has made nearly impossible to grow. This is the first article I wanna read, and the second one is this one. From quantum spam to quantum minds. Why the best revolution in physics is only getting started. So we're talking about Quantum 2.0 or something like that. I quickly saw in the article down there when I was fast reviewing or overviewing the article, because I have to know if there's too many hard words to read and understand for me. So, of course, let's start with the first article from Global English. Editing by Farley Ladgerwood, February 28, 2026. The classic photo or picture. Let's start. How's the music too loud? Maybe. For me, it's a little bit loud, yes. Let's go. Growing up, kids disappeared for hours and nobody called the police. I spent entire summers roaming the neighborhood with a pack of other kids, coming home only when the street lights came on. My parents had no idea where I was most of the time, and that was a completely normal thing to do. Compare that to today, where we track our kids every moment through smartphones and worry if they're out of the sight for 5 minutes. We've engineered childhood into this carefully controlled experience, thinking we are doing better. But here's the uncomfortable truth. We might have accidentally weakened an entire generation in the process. The accidental experiment that worked. The 1960s and 70s weren't trying to create emotionally resilient kids. Parents back then weren't reading child psychology books or attending parenting seminars. They were just trying to get by, often working multiple jobs, dealing with their own struggles. Kids were left to figure things out on their own. How many of you are from these generations? Chair Hilschenflanz, an author who studied this phenomenon, puts it perfectly. This bred self-reliance, one of the core mental strengths now in shorter supply. Think about it. When I was young, if I got bored, nobody entertained me. There was no iPad, no scheduled activities every afternoon. I had to create my own fun. Sometimes that meant building a fort in the woods. Sometimes it meant getting into arguments with other kids and figuring it out how to resolve them without adult intervention. Research shows that permissive parenting in the 1970s, characterized by reduced discipline and increased autonomy, led to children developing self-reliance and problem-solving skills. We weren't special. We were just left alone enough to develop these abilities naturally. Building emotional calluses the hard way. You know what happens when you protect your hands from everything? They stay soft. The first time you try to do real work, you get blisters. But if you work with your hands regularly, you develop calluses. Those calluses protect you. The same principle applies to emotions. Growing up as the middle child of 5 in a working-class family in Ohio, I learned early that not every disappointment warranted a meltdown. My father worked double shifts at a factory. If I scraped my knee or didn't get picked for the team, there wasn't always someone around to comfort me immediately. Dr. Mark Brackett, director of Yale's Center for Emotional Intelligence, notes that this forced development of internal emotional regulation is something psychologists now recognize as crucial for mental health. We had to learn to self-soothe. We had to figure out how to bounce back from setbacks without someone constantly validating our feelings. Was it always pleasant? Hell no! But it built something invaluable. Emotional durability. The patience nobody teaches anymore. Here's something that will sound crazy to younger folks. We used to wait for things, not just minutes or hours, sometimes days and weeks or months. If you wanted to watch a specific TV show, you had to be there when it aired, or you miss it forever. If you wanted to buy something, you saved up for months. Studies suggest that children of the 1960s and 70s developed patience and frustration tolerance due to fewer choices and less immediate gratification, leading to greater emotional endurance. My own kids, now adults themselves, grew up in a different world. Sarah, my oldest, can get anxious if Amazon takes 3 days instead of 2 to deliver. It's not her fault. The world trained her to expect instant everything. But those of us who grew up waiting, we developed a different relationship with time and desire. Solving problems without Google or grown-ups. What did you do when you got lost before GPS? You figured it out. You asked strangers for directions, looked for landmarks, maybe even accepted that you would be late. You develop intuition and problem-solving skills because you had to. Researchers indicate that children growing up in the 1960s and 70s developed emotional resilience through unstructured play and self-directed problem-solving, fostering independence and coping skills. Nice! I'm from 1979, the last year of that generation. Every summer, we would build elaborate treehouse with zero adult supervision. Did we occasionally fall? Sure. Did someone sometimes hit their thumb with a hammer? Absolutely. But we learned to assess risk, to help each other, to solve problems creatively, with whatever materials we could find. Today's kids often don't get these opportunities. Everything is supervised, safety-proofed, and structured. The playground equipment is designed to eliminate any possibility of injury, but also any opportunity for real risk assessment. Wow. The unintended consequences of comfort. Don't get me wrong, I'm not saying we should go back to the complete hands-off approach of the past. I missed too many of my own children's school plays and soccer games due to work. Something I still regret. There's value in being present and engaged as a parent. But we've swung so far in the opposite direction that we've created a generation that struggles with basic emotional regulations. They've never had to develop those calluses because we've protected them from every possible discomfort. When everything is comfortable, nothing prepares you for discomfort. When every problem is solved for you, you never develop problem-solving skills. When every emotion is immediately validated and soothed, you never learn to self-regulate. The irony is striking. I'm trying to be better parents. In trying to be better parents than previous generations, we may have accidentally handicapped our children emotionally. We gave them everything except the chance to develop resilience. Final thoughts. The 60s and 70s, the 1960s and 70s weren't perfect, far from it. But the imperfection, that benign neglect, that lack of constant supervision and comfort, it created something valuable. It forced kids to develop emotional skills that no amount of therapy or self-help books can easily replicate later in life. The challenge now isn't to recreate the past, but to find ways to give kids controlled doses of discomfort, independence, and problem-solving opportunities. Because those emotional calluses, they're not signs of damage, they're protective layers that help us navigate life's inevitable changes. Sometimes the best thing we can do for our kids is less, not more. Sometimes the struggles we protect them from are exactly what they need to grow strong. And that's all. Nice article. Easy to read for me. Oof. Let's go to the quantum physics articles and see how it goes. From quantum spam to quantum minds. Why the best revolution in physics is only getting started? Physicist Paul Davies looks back at the past century of quantum mechanics, the most disruptive theory in the history of modern science. By Ga-Young Lee. March 1st, 2026. 2 days ago. Very new. Nice. Let's go. The use of the word quantum has become rather hackneyed. I don't know what that means. There are quantum computers, quantum sensors, and even quantum refrigerators. What? The list is endless. I mean, what's next? Quantum washing machines? I think I'm gonna change the music. Wait for me, please. Because quantum is another thing. Let's go with... let me think. Which album? Oh, this one. No. Okay, let's go with this one. So, what's next? Quantum washing machines? If all the quantum spam has left you exhausted, Paul Davies' new book, Quantum 2.0, The Weird Physics Driving a New Revolution in Technology might help. Yes, the title has the Q word, but for the best possible reason. Starting with a brief rundown of what quantum actually means. I saw a Twitter yesterday, define what is quantum physics without using the word quantum. Starting with a brief rundown of what quantum actually means, the book lays out in plain language how quantum mechanics changed science in the past century and how it will continue to do so going forward. Paul Davies is a theoretical physicist and the director of the Beyond Center for Fundamental Concepts in Science at Arizona State University, a renowned science communicator. He has authored more than 20 books on topics from the origin of life to the nature of time. Gizmondo spoke to Davies about navigating the so-called quantum noise and how best to understand what quantum mechanics has contributed to our understanding of the universe. The following conversation has been lightly edited for grammar and clarity. So, Ga-Young Lee from Gizmondo. So, that's the interviewer, right? So, the book's title is Quantum 2.0. That implies there was a Quantum 1.0 or 1.0. What was Quantum 1? What was the turning point that brought us to Quantum 2.0? Paul Davies answers, very good question. The technical term for the branch of quantum physics we're talking about is quantum mechanics, which began in 1925. This is the most successful scientific theory ever because it explained the nature of matter, all the way from subatomic particles right up to stars. It also led to some very familiar technology that underpins much of the modern world. For example, the laser, microchips, MRI machines, and nuclear power. Your cell phone is packed full of quantum gizmos. All of this stemmed from what we're calling Quantum 1.0, which is the quantum mechanics developed 100 years ago. With the centenary last year, UNESCO declared 2025 to be the International Year of Quantum Science and Technology. It's very clear that there is a whole new quantum revolution that is bursting upon us. And the distinction is really the following: with Quantum 2.0, it's possible to manipulate individual particles, electrons, or photons, for example, and to sculpt their quantum states so that information is actually encoded in the individual particles themselves and not in the bigger devices, like transistors or gates. Oh, okay, I got it. They're processing information through subatomic mechanisms. Wow. With this revolution today, it seems like everyone is attaching quantum to things. What does that really mean? What makes something quantum? It was the same with AI a couple of years ago, or 3 or 4 years ago, right? Well, if it's not a commercial trick, and it generally is, then in the past people usually won't say you must go for a quantum MRI scan, but that uses quantum machine mechanics. But that uses quantum mechanics, Or you wouldn't say we are going to build a quantum nuclear power station, although that uses quantum principles. With Quantum 2.0, quantum usually is a signature of something exploiting the subatomic world. It's not just a gimmick. It means manipulating quantum physics in some non-trivial ways by utilizing concepts such as entanglement, or superposition. Question: strictly speaking, quantum effects influence everything in the universe, but they're also often in conflict with observable reality. It seems that scientists don't know exactly how the two are connected. Yet, if Quantum 2.0 is here, it means we're using these obscure ideas to create tangible things. Is that what that was a question? Was that a question? Quantum mechanics is full of paradoxes and weird concepts, the answers from Davis, of course, that just doesn't mesh with the everyday world. In everyday life, we have things like tables and chairs that we assume really exist independently of us measuring them or looking at them. But down at the atomic level, that isn't the case. A particle like an electron simply does not have a full set of properties before measurement. If you ask, well, before the measurement, did the particle really have both a position and a motion? The answer is that you cannot say. Even nature doesn't know what properties the particle had. That's a big claim. The big difficulty is interfacing that shadowy world of the quantum interfacing. The big difficulty is interfacing that shadowy world of the quantum where things don't exist in definite, well-defined states with the everyday world where everything seems a single concrete really. I'm lost. Sorry, I have to start again. The big difficulty is interfacing that shadowy world of the quantum where things don't exist in definite, well-defined states with the everyday world where everything seems a single concrete reality. Even after 100 years, physicists are squabbling over how to interpret that. It remains an outstanding problem for the next generation of physicists. Okay, this article is getting harder and harder to read for me. Your book offers many examples of how quantum science has left its mark on science. Is there any particular one you would like to highlight? There's a whole chapter in the book on quantum biology. One of the founders of quantum mechanics, Erwin Schrödinger, realized in 1925 that within a few years quantum mechanics could explain the nature of matter, all the way from subatomic particles up to stars, but living matter seemed to have its own laws. To a physicist, life looks like a miracle. Yes, it is. In 1943, Schrödinger gave a series of lectures called "What is Life?" He hoped that the powerful nature of quantum mechanics might explain the strangeness of living matter. But he was also open to the possibility that there may be something beyond quantum mechanics, some new kind of physical law, he said, prevailing in living matters. In recent years, people are considering effects like superposition and entanglement, or possibly even quantum information processing, going on in living organisms. I myself am a little bit skeptical, but it's intriguing. Might life's apparently miraculous capabilities ultimately be an exploitation of some sort of profound type of quantum mechanics? I don't know. At the start of the book, you write that quantum is the science that gave us AI. How exactly did quantum mechanics give us AI? Wow, I didn't know that. There are two sides to this. One is AI as we know it, but the other is the possibility of what I call quantum artificial intelligence, which would be an even greater leap and even more disruptive. What? I even can't imagine that. Let's answer your original question. AI is really just the outcome of doing a very large number of very rapid information processing on a very large scale. If you sat down and tried to work out the number of quantum devices involved in AI, there would be hundreds of components. There would be hundreds of components that fundamentally depend upon quantum mechanics through its principles. But a quantum AI will have a very different type of consciousness from us, because it would see all possible realities at once. According to quantum mechanics, it would be able to roam freely across the space of infinite possibilities and somehow capture all of this in its mind at once. So it would be not just a supermind, but a truly alien supermind. On that delightful note, if Quantum 1.0 was sketching things out in the scientific realm and Quantum 2.0 is manipulating individual quantum systems, what would need to get a Quantum 3.0? And should we be excited or terrified? Davis answers, interesting question. I haven't been asked about that before. But what occurs to me immediately stems from the answer I just gave you about quantum AI. Some people are excited by the possibility of what's called a mind-machine interface. We have layer 0 from Neuralink. We shared an article about that a couple of days ago, I believe. One example that I find deeply intriguing are helmets that you can wear with quantum magnetic sensors in them. These helmets can measure tiny flickering magnetic fields in your brain in very high resolution. With a refinement of this, they could literally read your thoughts. So, Quantum 3.0 could be where we poor human observers, who are just limited to seeing in a tiny fraction of the universe, could couple our brains in some way to quantum computers. Then we could probe these other possible realities by coupling the human consciousness to quantum consciousness. And that would be my Quantum 3.0, terrifying and intriguing to an equal degree, but I think we're quite a long way from getting there yet. Really? I feel, another question from Gizmondo, I feel like these examples demonstrate how closely quantum science is linked, philosophically speaking, to things that define our humanity, like consciousness or personal and intellectual desires. The big shock of quantum mechanics is that observations don't uncover reality, they create it. Davis answers, there's no doubt about it that starting about 1900, the word quantum was formed in 1899. There was a feeling that although we didn't know everything about the world, we sort of understood its conceptual foundations, that the world consists of material particles that really exist. The big shock of quantum mechanics is that observations don't uncover reality, they create the reality. That's a very weird thing. It seems that the act of observation brings into being the concrete reality that you observe. And that's really what 100 years of quantum mechanics has done. It's transformed our understanding of what it means for something to exist, what it means for something to have properties, and the relationship between the observer and the observed. And these are unresolved issues. There is no consensus as to how to make sense of it. So, again, it's a job for the next generation of physicists. The next 100 years. Quantum 2.0, the weird... It's over? Okay, it's over. That's just the title. Very interesting insights from Mr. Who's the interviewed? Okay, the author is Guy-Yun Lee and Mr. Paul Davies. Or Davies. Fantastic, 2 articles for today. I thank you very much for being here. Have a great day. See you the next one. Goodbye. Have a good one.
Come on and cry me a river, cry me a river. I cried a river